All right, everybody. So we are going to continue our use of the mole map with the mole map part 2. And this is something called stoichiometry. Which is a mouthful and a little bit hard to spell, but you guys can do it. All right, so stoichiometry is what happens when you are converting from moles of A to moles of B. So stoichiometry happens when you cross between these two boxes. So let's fill in our map. All right. So up above we have moles of A. And so this is going to be moles of B. Up above we had grams of A. This is going to be grams of B. And here we are going to have particles of B. All right. Let's fill in our arrows. We're going to start with what we already know. So going between moles and grams of B, we're going to need to know the molar mass. And going between moles and particles of B, we are going to need to use Avogadro's number. I'm going to leave it up to you to fill in which way you need to flip the conversion factor for those. In between moles of A and moles of B, we're going to need something called the molar ratio. So if you're going from moles of A to moles of B, you would want to have moles of A on the bottom, moles of B on the top, and vice versa on this side. And the molar ratio comes from the coefficients of a balanced equation. All right, so what am I talking about here? Well, let's take an example. And the example I'm going to be using is called the Haber process. The Haber process is a way to take nitrogen, which as you may recall makes up about 80% of the atmosphere, and combines it with hydrogen to make ammonia. Why would you want to do this? Well, ammonia is a building block for artificial fertilizers. It's also a building block for making certain kinds of explosives. There's a whole lot of interesting and problematic history evolved around this chemical reaction, but it was a crucial reaction that shaped history. So you should look it up. But for right now, let's use this as an example of a reaction that we can use for practicing with stoichiometry. So as I mentioned, the molar ratio is something that comes from the coefficients of a balanced equation. So the first thing that we need to do is to see if any equation that we're looking at is balanced. And just taking a look at this, we have different numbers of nitrogens, hydrogens, on both sides, so we need to balance it. Just seeing that there's 3 hydrogens here and 2 here makes me think that we probably need to go 3 there. And there's 2 nitrogens here and 1 there, so I'm going to put 2 there, and I think that balances it out. Yep, we've got 2 nitrogens and 2 nitrogens and 6 hydrogens and 6 hydrogens. Okay. So let's take a look at this first problem. If you want to make 10 moles of ammonia in H3, how many moles of nitrogen should you order? Okay, so we need to figure out where we're going on the map, and we're going to typically, whatever is given to you is going to be substance A, and whatever you want is substance B. So I'm going to call this A, and I'm going to call this B. All right? So again, on the map, if we're going from moles of A to moles of B, we need the molar ratio, and we get that from the coefficients. So what I can see here is that I have 10 moles of A, or you could call it 10 moles of ammonia, however you want to do it, times the molar ratio. And the molar ratio would be the ratio of nitrogen to ammonia. So let's figure this one out. The coefficient in front of nitrogen is 1. The coefficient in front of ammonia is 2. We ought to have the ratio of B to A here. So we want to have 1 mole of B per 2 moles of A. All right? And so this means that if we want to get 2 moles of ammonia, we need 5 moles of nitrogen. Okay. So one more time, we use this ratio, 2 ammonias to 1 nitrogen. Let me try this over with that. So we have 1 mole in 2 moles in H3, and H3. So moles of ammonia cancel out, and we're left with moles of nitrogen. Once you have problems that use 2 substances, you need to actually not only label your units, but you label them as units of a certain substance to help you keep track of things. All right, let's try another. You react 45 grams of hydrogen. I'm going to write that down as my given. 45 grams hydrogen with an excess of nitrogen. So an excess means you've got plenty of it. You won't run out of nitrogen. This means essentially when we're doing these word problems that you can largely not worry about whatever you have an excess of. How many moles of ammonia will you produce? So we're being asked for moles of ammonia. So we're starting at grams of A, and we're going to moles of B. So let's see how that looks on our map. Going from grams of A to moles of B, and that means we're going to have to convert from grams of A to moles of A, and from moles of A to moles of B. So we're going to need 2 separate conversion factors, the molar mass of A and the molar ratio. So if we have 45 grams of H2, we're going to multiply that by the molar mass conversion factor. We want to have grams on the bottom and 1 mole on the top. We've got to figure out what the molar mass of hydrogen is. Well, hydrogen is 1.0, so the molar mass of H2 is 2 grams per mole. So we have 1 mole per 2 grams. Right, that's our first conversion factor. Our second conversion factor is the molar ratio. We need our balanced equation again. So we're going from hydrogen to ammonia, and so that's 3 hydrogens to 2 ammonias. We want to put that with ammonia on top and hydrogen on the bottom. Okay, so let's cancel this out. Oh, I didn't do what I told you to do, which is to keep track of substances. All right, we have grams of hydrogen that can cancel out, moles of hydrogen that can cancel out, and we're being left with what we want, which is moles of ammonia. So you can see here that the 2's will also cancel out. So we've got 45 divided by 3, which means we have 15 moles of ammonia as our answer. All right. Lastly, we have 3.24 times 10 to the third grams. I'm going to make that 3240 grams of ammonia. We're being asked for grams of nitrogen gas. All right, so this is a grams of A to grams of B problem. So that means we're going to need to convert from grams of ammonia to moles of ammonia to moles of nitrogen to grams of nitrogen. So we're going to need to have 3 different conversion factors: the molar mass of ammonia, the molar ratio between ammonia and nitrogen, and the molar mass of nitrogen. Alrighty. 3420 grams of NH3 times 1 mole NH3 over the molar mass of ammonia, so that would be 14 for the nitrogen, and 3 for the 3 hydrogens, so that's 17 grams per mole. So 17 grams ammonia. Now we need the molar ratio. The molar ratio is going to be 2 ammonias for every 1 nitrogen. And it's nitrogen that we want, so we're going to put nitrogen on top. 1 mole nitrogen, 2 moles ammonia. And lastly, we want to multiply this by the molar mass of nitrogen. So nitrogen is going to be 2 times 14, which is 28 grams per mole. So we multiply that by 28 grams of nitrogen over 1 mole of nitrogen. Okay, let's see if everything cancels out. All right, we've got grams of ammonia, moles of ammonia, moles of well, hang on just a second. Moles of ammonia, moles of nitrogen, and we're left with grams of nitrogen. All right, I'm going to ask you to pause this and calculate the answer. All right, 3,240 divided by 17 divided by 2 times 28 gives us 2,670 when you round it to 3 significant digits. All right, I hope that this helps. I'm probably going to have already posted some practice for you to do, so I hope that you try that out and ask me questions if you need it, and have a great day.